Hello and welcome back to this video series regarding the Intermediate Math League of Eastern Massachusetts. Today we're going to be continuing on with Algebra Meet 4, talking about how to solve systems of equations with substitution. So let's get right into it. So before we begin on solving systems of equations with substitution, just a quick note that everything that I'm going to be teaching in this video lesson, I'm assuming that you have the prior knowledge of what we've learned in the previous video lesson, which is how to set up systems of equations and how to solve those systems of equations with elimination. And if you're familiar with that, then feel free to keep watching. And if you're not, I'd recommend watching my previous video where I explain all of that. All right, so first we need to talk about how to solve systems of equations with substitution. And solving systems of equations with substitution just has a bunch of simple steps. And so the first step when it comes to solving any system of equations is always to set up the system in the first place. So when we set up a system, first we need to come up with variables to represent what we're solving for. Because if we're going to solve algebraically, we need variables to represent those numbers. So it says in the question, how old will Anna be in 4 years? And it doesn't really matter what the rest of the question says, but if we're solving for the age of somebody named Anna, then we need to come up with a variable representing how old Anna is right now. So we're going to call that variable A. So A represents Anna's age. Anna's age. All right, and then we need to come up with one other variable, and that's one that we're going to call C, which will represent Caroline's age, because Anna's age is based off Caroline's age in the question. For example, it's saying that Caroline is 3 years older than Anna is now. So if we're going to turn that into an equation, then we need a variable to represent Caroline's age as well. So I'm going to abbreviate that char, because I don't want to write as much. So char's age. Okay. So we have Anna's age and Caroline's age. So now we can come up with our equations. So in the question it says, 3 years ago, Anna was half as old as her sister Caroline was. All right. So it's saying, so 3 years ago, so we need to represent Anna's age 3 years ago, which is A, her age now, minus 3. So that's Anna's age 3 years ago, and she was half as old as her sister Caroline was, which means if we take her age and we multiply that by 2, because she was half as old, that should be equal to Caroline's age. So that's equal to C minus 3, or Caroline's age 3 years ago. Because C, which is her age now, minus 3 represents Caroline's age 3 years ago. So just to go over what this equation means, it's saying A minus 3, or Anna's age 3 years ago, multiplied by 2, since she's half as old, will be equal to the age of Caroline 3 years ago, or C minus 3. All right, so our next equation will be based off this piece of information. It says if Caroline is 3 years older than Anna now, and then we don't need to read the rest because that's for the question. So if Caroline is 3 years older than Anna now, that means Anna's age, or A, plus 3 should be equal to Caroline's age. So A plus 3 equals C. And now we have our two equations. So the second step of solving with substitution is always just to solve for one variable in one equation. So what that means is basically you want to pick one of your equations that you set up. And it doesn't matter which one, but most of the time you'll pick the more simple one because that'll be a little bit easier. And you want to just solve for one variable, and you can choose either variables to solve for. And you'll notice that when we created these equations, we actually already did that in the second equation. We have A plus 3 equals C. And we solved for C because C is all on its own. It's saying we could say C is going to be equal to A plus 3. And so that's what solving for one variable means. Now, if we hadn't had it already solved, I'll give you an example. So we had 2A, actually, no, that's a bad example. How about A minus 3 equals C plus 4, and we want to solve for C? Then we need to get C all on its own. So we need to get rid of this plus 4. So we subtract 4 from both sides because these will cancel out, and we get A minus 7 equals C. And so that's how you would do that if it wasn't already solved for. But I'll erase this because this isn't one of the equations we have in our question. All right, so we have A plus 3 equals C. So that step is already done. All right, so the next step, and this is where the substitution comes in, is to substitute what that variable that you solve for is equal to into the other equation. So we know that C is going to be equal to A plus 3, which means that, say we write out our first equation, 2A minus 3 equals C minus 3, right? So here's our first equation. If C is equal to A plus 3, and that's true no matter what, then we could rewrite this equation, and this is why it's called substitution, as 2 times A minus 3 equals A plus 3 minus 3. Because C minus 3 is the same as A plus 3 minus 3. Because C is the same as A plus 3. So that's why it's called substitution. Because you chose one of your variables and you substituted it with an equation that the other variable made it equal to. So now we have only A in this equation, and that's our substitution done. So the final step is just to solve for your variable algebraically. So we're going to solve for A here. So when you solve algebraically, and this is like something that you should know, you want to just simplify your equation and then isolate the variable. So first we want to get rid of any parentheses. So on this left-hand side, we can get rid of the parentheses by distributing, by multiplying 2 by A, which is 2A. Keep the symbol in the middle, and then 2 by 3, which is 6. So 2A minus 6 equals, and then A plus 3 minus 3. So that's going to just be A, because the plus 3 and minus 3 cancel out. So 2A minus 6 equals A. Okay, cool. So now we need to isolate the variable. And we can do this by subtracting the 2A from this side, because we want A on that side on its own. And subtracting 2A from both sides is the easiest way to do that. And I'll write the equation up here, so it's a little bit easier to see. So 2A minus 6 equals A. So if we subtract that 2A from both sides, because this is a positive 2A, like this, these cancel out. And you need to make sure to keep this sign here, this minus sign, because it's a negative 6. So you have negative 6 equals A minus 2A, or negative A. And then finally, we have negative 6 equals negative A. So therefore, we can cancel out the negatives and say A is equal to 6. A equals 6. And then the question reads, how old will Anna be in 4 years? So if Anna is 6 now, then 6 plus 4 equals 10. Anna will be 10 in 4 years. All right, so now I have a review question about solving systems of equations, and you should try to do it through substitution. You don't have to, but since we just learned it, I recommend that you try. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 54 years old. So let's read the question. It says, Caitlin is 34 years old than Abraham, 34 years older than Abraham. In 10 years, Abraham will be half Caitlin's age. How old was Caitlin 4 years ago? All right, so as in any substitution system of equations question, we need to set up the system as our first step. So let's create our variables. So we're finding how old Caitlin was 4 years ago, and that's pretty easy when we find her age. We can just subtract 4 from it. But let's create a variable that represents what Caitlin's age is now. We're going to call that C. So Caitlin's age. Caitlin's age. All right. And then we need one more variable, and that's going to be Abraham's age, because Caitlin's age and Abraham's age are kind of based off each other in the question. So A is going to represent Abraham's age, and I'm not going to write that entire thing out. Abraham's age. All right, cool, and I'll capitalize this. All right, so now we can start creating our equations. So first it says, in 10 years, Abraham will be half Caitlin's age. So if in 10 years, Abraham is going to be half Caitlin's age, then we need to represent Abraham's age in 10 years and Caitlin's age in 10 years. All right, so in 10 years, so A plus 10 is going to be Abraham's age in 10 years, right? And if he's going to be half as old as Caitlin is in 10 years, then if we multiply that by 2, then we can say that's equal to Caitlin's age after 10 years, or C, which is her current age, plus 10. So 2 times Abraham's age in 10 years is equal to Caitlin's age in 10 years. All right, so now we can set up our second equation. It says Caitlin, and I accidentally skipped over this when I was setting up my first equation, because this is actually the second piece of information. I just didn't see this part first, but we can still set it up. It says Caitlin is 34 years older than Abraham. All right, so if Caitlin is 34 years older than Abraham, then that means if we take Caitlin's age, so C, and subtract 34 from it, so C minus 34, then that will be equal to Abraham's age. Yeah, so C minus 34, Caitlin's age minus 34 is equal to Abraham's age now, because Caitlin is 34 years older. So now we have our two equations. All right, perfect. So we can move on to the second step of solving with substitution. And that step is to solve for one variable in one equation. And you'll actually see this pretty commonly, that it's done for you when you create these equations. And in this second equation, it's done for us, because we have C minus 34 is equal to A. And so we solved for A in this equation. All right, so our third step is then just to substitute. So if we know that A is equal to C minus 34, then in our original question, wherever A is, we can replace that with C minus 34. So 2 times C minus 34, which is previously A, then plus 10 equals, and then C plus 10. All right. So now we just need to, since we substituted in for A, we got A out of the equation. Now we can just solve algebraically for C. And if you originally wrote this equation up here as C equals A plus 34, and then substituted to eliminate C from the equation, that's also fine. You can solve for Abraham's age and then use that information to figure out Caitlin's age, right? So say you figure out Abraham's age was 20. If Caitlin is 34 years older, then just add 34 to that. But since we eliminated A from the equation by substituting it out, we can solve directly for Caroline's age. So solving algebraically is pretty simple. We should need to get rid of any parentheses to simplify the equation first. So first we have this big parentheses. We have C minus 34 plus 10, which can just simplify to C minus 24. And I'm sorry, that was a bad 10. There we go, 10. So that simplifies to C minus 24. And so I'll just erase this to get it out of the way and just rewrite it. So we have now, instead of 2 times C minus 34 plus 10, we have 2 times C minus 24 equals C plus 10. And then one more simplification step. We just need to distribute this multiplication of 2. So we do 2 times C, or 2 times C, and then keep the symbol in the middle, the minus, and then 2 times 24, which is 48. So 2C minus 48 equals C plus 10. All right, now we need to isolate the variable. So I'll choose the left-hand side to get the variable on. So we need to get rid of this minus 48 by adding 48 to both sides of the equation so they cancel out, because you do the opposite operation of the same number. So these cancel out, and then we get 2C equals C plus 58. And then finally, we can, and I'll write it up here so we have more room, 2C equals C plus 58. And then finally, we need to get rid of this C on this right-hand side of the equation, because we want our C to be on the left-hand side, because we're isolating the variable. So we can subtract C from both sides of the equation, because this is a positive C. So this will cancel out, and this will get us 2C minus C, which is just 1C, equals 58. So Caitlin's age now is 58. And then make sure you read the question, because 58 isn't the answer. It says, how old was Caitlin 4 years ago? So we do 58, which is her age now, minus 4 to represent her age 4 years ago, equals, and then that's 54. All right, and finally, we need to talk about a little bit more complicated systems questions, which are systems of equations with more than 2 equations, or more than 2 unknown variables. So solving a problem with more than 2 unknown variables is actually just really similar to solving if you only have 2 equations. There are just a few more steps. So I have an example question here that I'll go over how to solve with steps. So it reads, together Jim and Bob weigh 357 pounds. Together Jim and Larry weigh 393 pounds. And the combined weight of all three men is 565 pounds. How much do Bob and Larry weigh together? All right, so in this question, before we create our equations, as usual, we need to come up with our variables. So first, it's asking us to find how much do Bob and Larry weigh together, which means we need to create a variable for Bob's age, which we'll call B, or sorry, not Bob's age, Bob's weight. Bob's weight. And I'm not going to write these out after this because it takes a while. So B is Bob's weight, and then L will represent Larry's weight. And I think we can remember that since it's L, as in Larry. And then also, but we also have a third person in this question, which is Jim. And we have pieces of information like this one based off Jim's weight as well. So we need a third variable, J, to represent Jim's weight. All right, so now we have our three variables, B, L, and J. And I'm actually going to erase this because I need a little bit more room, and I think we can remember what each of those variables stand for. So now we can start creating our equation. So first, our first piece of information says Jim and Bob weigh 357 pounds, which means if we take Jim's weight, or J, and add it to Bob's weight, or B, that's going to give us a total of 357. 357 pounds. All right, our second piece of information is together, Jim and Larry weigh 393 pounds, which means if we take Jim's weight, J, and add that to Larry's weight, which is L, that will equal 393. 393, okay. And then finally, and we have a third piece of information, the combined weight of all three men is 565 pounds. So if we take Jim's weight, J, and add that to Bob's weight, B, and add that to Larry's weight, L, so J plus B plus L, all of their weights, that gets us 565 pounds. And then how much do Bob and Larry weigh together? And that's not a piece of information that we can create an equation based off of. So we can actually just stop there, and now we have our system of equations. So next we need to choose whether or not we want to use elimination or whether or not we want to use substitution. And in this question, I'm actually going to use elimination, which we learned in the last video lesson, because it's just a little bit more efficient to solve for one specific variable. And here's what I mean by that. So if we take our third equation, which is J plus B plus L equals 565, and say we can choose either of these equations. We'll take the second one, J plus L equals 393. So if we know J plus L equals 393, you can see how we can do or use elimination with these two equations, right? Because if we subtract these two equations, well, the J's cancel out, the B subtracts with nothing, so we just have a B below, and these L's cancel out. And so B is going to be equal to 565 minus 393. And then, so 565 minus 393 is, give me 1 sec to do this in my head, 172, I believe. Yeah, 172. So Bob's weight is 172 pounds. And so that's why I chose elimination with this one, because not that substitution wouldn't work, elimination was just a little bit more efficient. So since we know that Bob's weight is 172 pounds, now we can use that to figure out what Jim's weight is, and then we can use that to figure out what Larry's weight is, right? Because if we know that Jim's weight plus Bob's weight, which is 172, equals 357 pounds, and this is where we use our first equation here, then we can solve for Jim's weight on top of that. So Jim's weight is going to be, and we just need to solve for J by subtracting 172 from both sides of the equation. These cancel out, so Jim's weight will be 357 minus 172, and that's going to be 185 pounds. J equals 185. All right, and then now we can use Jim's weight to solve for Larry's weight. And remember, the reason we have to do this is because it says, how much do Bob and Larry weigh together? So we know Bob's weight, but we need Larry's weight as well. So if we know Jim's weight, J plus L equals 393, and Jim's weight is 185 pounds, then 185 plus L equals 393. And then to solve for L, we subtract 185 from both sides of the equation. These cancel out, and it leaves us with L equals 393 minus 185, and that gets us to 208. 208. All right, and then finally, if it's asking how much do Bob and Larry weigh together, we take Larry's weight, which is 208, we take Bob's weight, which is 172, and we add those to get 172, 380. 380 pounds together. All right, and finally, I have a review question with solving a system of equations with more than two variables. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was $41. All right, so let's read the question. It says, at Gianni's Italian restaurant, 2 pizzas and 1 sub cost $38. 1 pasta bowl and 1 sub cost $19. And 1 pasta bowl, 1 pizza, and 1 sub cost $34. How much do 2 pizzas and 1 pasta bowl cost? All right, so with any systems of equations question, our first step is just to come up with our equations. So let's create our variables. So first, it wants us to solve for how much 2 pizzas and 1 pasta bowl cost. So we need to create variables to represent the cost of a pizza and the cost of a pasta bowl. And I'm going to use P to represent the cost of a pizza. And I know that pasta bowl and pizza start with the same letter, but there's a reason, and that's because pasta bowl actually is 2 words. So I'm going to use the letter B to represent the cost of a pasta bowl. And I'll keep that written out just because it might get a little bit confusing. But think of B as in the word bowl. So B represents the pasta bowl. And then finally, there's one more cost that we have in this question, and that's the cost of a sub. So we're going to use the variable S to represent the cost of a sub. All right, so now we have our 3 variables, P, B, and S. And now we need to come up with our equations. So first it says 2 pizzas and 1 sub cost $38. So 2 pizzas, or 2 times P, plus the cost of a sub, which is S, so 2P plus S, will get us $38. 1 pasta bowl and 1 sub cost $19. So pasta bowl is B, so the cost of a pasta bowl, plus the cost of a sub, which is S, so B plus S gets us to $19. And then 1 pasta bowl, 1 pizza, and 1 sub cost $34. So 1 pasta bowl, B, plus the cost of 1 sub, or S, plus the cost of 1 pizza, P, or all 3 of them together, equals $34. And then it says, how much do 2 pizzas and 1 pasta bowl cost? And we can worry about that later, but that's not a piece of information. So now we've created all of our equations. All right, so since we created our equations, now we need to just choose one variable to solve for. Because once we solve for one of these variables, we can pretty easily figure out the others using these equations. And the way I'm going to do that is, again, through elimination. Because you'll notice this one is B plus S plus P, and this one is B plus S, which means we can probably eliminate the B and the S's if we subtract. So if we set up these equations like this, so B plus S plus P equals 34, and then under it, set it up for subtraction. So B plus S equals 19. Then when we subtract, these B's cancel to get 0. And then these S's cancel to get 0. And then the P, well, you're not subtracting anything from the P, so that just carries down to the bottom. So P equals 34 minus 19. And 34 minus 19 is 15, which means that the cost of 1 pizza, P, equals $15. Because remember, these zeros don't do anything. All right, so if we know that the cost of a pizza is $15, then we're not done yet just because we don't know what the cost of a pasta bowl is. And we need that in order to figure out the cost of 2 pizzas and 1 pasta bowl. And the only other cost that we can directly figure out by knowing the cost of a pizza is by using the first equation to figure out the cost of a sub. So if 2 times the cost of a pizza bowl, which is, or sorry, not pizza bowl, pizza, is $15, and then plus the cost of a sub is 38 total, then we can just solve for s. So 2 times 15 is 30. 30 plus s equals 38. And then that means s is going to be 8, which you might be able to already see, but if you solve it algebraically by subtracting 30 from both sides to get rid of this 30 here, we get s equals 38 minus 30, or $8. So the cost of a sub is $8. And then finally, we can use that to figure out what the cost of a postable is. Because b, which is the cost of a postable, plus s, and we know a sub costs $8, so b plus 8 equals 19. Which means that if we get rid of this 8 to solve for b by isolating the variable, then we get b equals 11. All right, so the cost of a postable is $11. So now finally onto the question. It says, how much do 2 pizzas and 1 postable cost? So if we take the cost of a pizza and multiply it by 2, because we have 2 pizzas, so 2 times 15, plus the cost of 1 postable, which is $11, so plus 11, that's going to be equal to 30 plus 11, which is 41. All right, just to quickly review what we've learned this lesson. So we started by learning how to solve systems of equations through substitution, and that had a few main steps. The first step, which is always the same, is setting up the system of equations. Then what you want to do is choose one of the equations, which is, you'll probably choose the more simple one because it's a little bit faster, and just solve for one of the variables in that equation. Then the next step is to take what that variable is equal to and just use that to substitute in the other equation, and then solve that equation algebraically for whatever variable is left. And then next we did a review question where we found Caitlin's age 4 years ago was 54 years. Then we learned about problems with more than 2 unknowns, which is actually really similar to systems of equations with just 2 unknowns. And what we just have to do is come up with more than 2 equations and use more than 2 variables, but the methods that you can use are just the exact same, except it'll take more steps. And then finally, we did a review question where we found that at Gianni's Italian restaurant, if you want to order 2 pizzas and 1 pasta bowl, that is $41. All right, so that's all I have for today's lesson. I hope it's helpful, and I'll see you next time.